In this video, we're going to carry on to look at the next type of advanced questions for chemical calculations in the A-level syllabus. We are going to look at combustion analysis type of questions. In combustion analysis questions, it usually goes like this. You have an organic compound, and most of the time we are looking at hydrocarbons undergoing or being subjected to combustion. And then given the mass or volume data, we can then find the empirical formula of the organic compound or the hydrocarbon. There are three main types of questions as shown here, and we will go through each one at a time. Now, before we even look at any of the question, it's very important to just recap that combustion is the reaction of a substance or compound with oxygen. Okay, and we have learned in O-levels also that when we subject an organic compound to complete combustion, we produce carbon dioxide and water. Okay, so if we are looking at a hydrocarbon, meaning a compound or an organic compound that contains only carbon and hydrogen, we can actually represent a hydrocarbon by a general formula that looks like this: CXHY, okay, where X and Y are integers. Now, by using this CXHY representation of an organic compound or hydrocarbon, we can actually construct a general equation for combustion, meaning the hydrocarbon reacts with oxygen to give carbon dioxide and water. Now, in order to balance the atoms of each element, you will find that you need to put the following coefficients: an X for carbon dioxide, a Y/2 for water, and then X plus Y/4 for oxygen. Okay, so when you are doing questions related to the combustion of hydrocarbons, this is the first thing that you should be doing, to write down the general equation for the combustion. In the first type of question, we'll be required to find the empirical formula given some volume data. And what kind of volume data will be given? From the question, we'll be able to find the volume of CO2, the volume of your oxygen that was reacted, as well as the volume of your hydrocarbon. So step number one for solving this type of question is to obtain from the question these three volumes before we move on. Next, we can make use of the general equation now, and we can compare the volume ratios using the numerical values in the question to the coefficients in the equation. Okay, bear in mind that we are looking at gases. For your CO2, for your oxygen, and for your hydrocarbon, we are looking at gases. So we have learned in O-levels that Avogadro's relation, as stated by Avogadro's relation, for reacting gases, the mole ratio is equals to the volume ratio. So for example, if we compare this X plus Y/4 to the mole ratio of your hydrocarbon, it will be equals to the volume ratio as given in the question. So right now we're going to look at how we can apply it to an actual question. So in this question, we are given the volume of a hydrocarbon. Okay, we are given volume of oxygen gas, but take note that this is in excess. So this doesn't represent the volume of oxygen that had undergone reaction. Okay, and then they went on to tell you that the residual gases occupy a volume of 80 centimeter cube, and when you pass the gases through potassium hydroxide, the volume decreases to 50 centimeter cube. So the first thing that you need to ask yourself is, what happens when you pass the residual gases through potassium hydroxide? Okay, and before that, maybe you need to think of what are the residual gases. Now, when you burn a hydrocarbon in excess oxygen, okay, the residual gases all right, upon cooling to room temperature, it would be made up of CO2, it will be made up of your excess oxygen. Okay, so based on this knowledge, we will be able to perform step number 1, which is to find the volumes of your hydrocarbon, find your volumes of CO2, and the volume of your oxygen reacted. The volume of your hydrocarbon is given in the question. The volume of CO2 is equal to the reduction in volume after passing the residual gases through potassium hydroxide. Why is that so? Because potassium hydroxide is an alkali. It will react with your acidic gases in the form of carbon dioxide. So in this case, the volume of CO2 would be 30 centimeter cube, and the volume of oxygen reacted, remember the remaining gases, residual gases after passing through potassium hydroxide would be your O2 excess. Okay, so given that we started with 100 centimeter cube of oxygen gas, and after the combustion we have 50 remaining, the volume of the volume of O2 reacted would be 50 centimeter cube. This is step number 1. Step number 2, then we compare the volume ratio to the coefficient ratio in order to find X and Y. So for example, if we were to compare the ratio between your hydrocarbon and carbon dioxide, we would have the following ratio in the coefficient X over 1, and the ratio between the volumes would be 30 over 10. Okay, that would tell us that X is actually equals to 3. Now if we were to compare the ratio between your hydrocarbon and your oxygen reacted, okay, by comparing the coefficients again, we will have X plus Y over 4 divided by 1, and that is equal to the volume ratio of 50 over 10. Okay, that means that X plus Y over 4 is equals to 5, and given that X is equals to 3, we can find that Y is therefore equals to 8. That means the formula of the unknown hydrocarbon is C3H8. The next type of question is similar. So given volume data, we are required to find the formula of a hydrocarbon. However, instead of being given the volume of each gas directly, you'll be given the change in volume, meaning the change in volume of gases before combustion and then after combustion. So for such questions, we will often see the following keywords, either expansion or contraction. So when you see these two words, you should know that it's talking about a change in volume. Now, to solve questions like this, there are 2 steps. Step number 1 is very important. You first need to determine which volumes make up the initial volume, the total initial volume, and which volumes make up the total final volumes. For example, if you think about it, before combustion, the volume of gases would be the volume of your hydrocarbon plus your oxygen gas that was added. And if your oxygen gas is added in excess, this oxygen gas would be a sum of the volume of oxygen that actually undergoes reaction with your hydrocarbon plus the volume of oxygen that is remaining, that is in excess. So these 3 volumes would make up the total initial volume, and after combustion, the volumes of gases that make up the final volume will be that of your carbon dioxide produced as well as the unreacted oxygen gas. Now in case if you are wondering about water, usually for combustion analysis there will be this line that says that the volumes are measured under room temperature pressure, or where the temperature has been cooled down to room temperature. So at room temperatures, your water would no longer be a gas. Step number 2, we now need to equate expression to find to delta V, the numerical value of delta V that is given in the question. So for example, if they tell you that there's a contraction in volumes there's a contraction of 50 centimeter cube. Contraction means that the final volume is smaller than the initial volume, so we need to take Vi minus Vf, all right, and equate to the number. If they tell you that the volumes of gases expanded by 50 centimeter cube, then we will take Vf minus Vi and equate to 50. Now, upon comparing the final and initial volumes to your change in volume, we then will be able to find the volumes of CO2 or the volumes of O2 reacted from this step. After finding your volumes of hydrocarbon, CO2 and oxygen reacted, we can use the step that we have learned in the previous type of question by comparing mole ratios to the volume ratios, and from there we can work out X and Y. So this is an example. In this example, we are given the volume of your hydrocarbon, which is 30 centimeter cube. It is exploded with this volume of oxygen, and then after that there is a contraction of 90 centimeter cube. Okay, and then there is a special piece of information over here talking about this chemical called pyrogallo, and pyrogallo can actually absorb your oxygen gas. Okay, absorb oxygen gas. So from there, if you read further treatment with pyrogallo, there was a reduction of 20 centimeter cube. That tells us the other thing, that your volume of oxygen excess is actually 20. Okay, so right now we still don't have enough data to jump straight to step 3, so we need to work on this contraction of 90 centimeter cube in order to gather more data, which is like the volume of your CO2 produced. Okay, so since there's a contraction, it means that your initial volume is larger than your final volume, and then is equals to 90 centimeter cube. Previously, we have looked at the volumes that make up your initial volume and final volume. So I'm going to quickly write down. Initial volume would be made up of your hydrocarbon, VO2 reacted plus VO2 excess. Okay, and then your volume final would be VCO2 minus VO2 excess. Okay, over here you can see that we have two instances of VO2 excess, and it actually cancels out. So now let's put in the volumes that we already know. We know that there's 30 centimeter cube of your hydrocarbon. VO2 reacted, actually we can find out as well, because the total volume of oxygen is 200, and then the volume of oxygen in excess is 20. So the volume of O2 reacted is actually 180 centimeter cube. So this is 180. We don't know the volume of CO2, so we leave it there, and then is equals to 90. So with that, we'll be able to find that the volume of CO2 is actually 120 centimeter cube. So once we have found out the volume of CO2, then step number 3 is similar as before. We compare the mole ratio, or rather we compare the ratio between your hydrocarbon and CO2. That would give us the following equation. X over 1 is equals to 120 over 30. That will give us X equals to 4. And then when we compare the ratio between your oxygen reacted and hydrocarbon, that will give us X plus Y over 4 is equals to 180 over 30. And that would again give us, this is 6 minus 4, 2, Y equals to 8. Okay, so therefore we can find out the formula, which is C4H8. In the third type of combustion analysis questions, we are not given volume data, but instead we're given mass data. Okay, and one other typical thing about such questions is that instead of looking at a hydrocarbon, we can look at that of an organic compound, right? So it no longer contains only carbon and hydrogen, but it can contain carbon, hydrogen, and oxygen. And in the question, you'll be given the mass of carbon dioxide, water, and also the organic compound. So step number one, from the question, we need to figure out the numerical value of your carbon dioxide, of your water, and also your organic compound. Sometimes it's given directly in the question, sometimes it's indirectly. So for example, they tell you that there's increase in mass of when the residual gases, when the product gases are passed into sodium hydroxide or potassium hydroxide, there's an increase in mass of a certain value. So that tells you that the increase in mass must be due to the mass of carbon dioxide. And sometimes they will tell you that they pass the product gases into phosphorus pentoxide. So phosphorus pentoxide is used to absorb water. So any increase in mass in phosphorus pentoxide will be equal to the mass of water that's being produced. Once we have found the numerical values for the three masses, your CO2, water, and your organic compound, the next step, we can actually make use of the mass of carbon dioxide to find the mass of carbon in the organic compound. And how do we do so? Is to recognize that the carbon in your organic compound would be completely converted to carbon dioxide. So from the mass of carbon dioxide, we can find the number of moles of carbon dioxide, which would tell us the number of moles of carbon. And from number of moles of carbon, we can find the mass of carbon that was present in the organic compound. Next, from the mass of water, we can actually find the mass of hydrogen in the organic compound. And why? Because all the hydrogen in the organic compound would be converted to water. So from the mass of water, we can find the number of moles of water. All right, and from the number of moles of water, we can find number of moles of hydrogen. Take note that there's a half over here. Okay, why is that so? Because it takes 2 atoms of hydrogen to make 1 molecule of water, or it takes 2 moles of hydrogen atoms to form 1 mole of water molecules. So to find number of hydrogen atoms, we need to take number of water, divide by 2. And then after that, we can multiply it by molar mass to find the mass of hydrogen. For the mass of oxygen, how do we find it? We can find it indirectly by taking the mass of your hydrocarbon, subtract away your mass of carbon and hydrogen, and then we'll obtain the mass of oxygen. Once we have obtained the masses of carbon, hydrogen, and oxygen in the organic compound, the next step is something that you will find very, very familiar. Now, we have learned in O-levels that given mass data, we can actually find the empirical formula of a compound. So it goes something like this. First, we list down the masses of the 3 elements, and then we divide the masses by your atomic mass to find the number of moles. And then we can find the molar ratio by dividing all the number of moles by the smallest value. So that would give us the empirical formula of the organic compound. So let's take a look at this example here. So we have an organic compound X, and it contains carbon, hydrogen, and oxygen. So and if we look at the question, we are given masses. We are given the mass of your organic compound, we are given the mass of carbon dioxide, we are given the mass of water. So first thing is to take note that we are looking at masses now, so we need the 3 steps. Step number 1 is to obtain the numerical value for the 3 masses, which is given directly in the question. Right. Step number 2 is to find the mass of carbon given your mass of carbon dioxide. So we convert carbon dioxide, the mass of carbon dioxide, to number of moles, which is equal to number of moles of carbon, and then we multiply by the atomic mass or the molar mass of carbon to find the mass of carbon in the organic compound. Next, we find the mass of hydrogen given the mass of water, and then we find the mass of oxygen by subtracting the mass of hydrogen and oxygen from that of the organic compound. And once we have the three masses, we can find the empirical formula using the table. All right, so we have the masses of your respective elements. You divide by your atomic mass, and then you find your number of moles, and then we find your mole ratio. Okay, in this case we have a ratio of 3, 6 and 1, so that means that the empirical formula of X is C3H6O.